Welcome to MyProjectBazaar.com. Let me discuss about the process defense against SSDF attack in cognitive radio networks. Attack aware collaboration spectrum sensing approach. Let me discuss about the abstract of the project. Spectrum sensing data falsification, that is SSDF attacks are detected in cognitive radio networks. In this proposed system, both primary user and CR users are deployed in the network. Among the CR users needed to detect the malicious users, which are intentionally reported wrong information to the fusion center. Here proposed K out in rule, which are provided the optimal K value that minimize the base risk. Finally, attack strength has been determined by the ratio of the number of malicious users to the total number of users. Security concerns are raised for collaborative spectrum sensing due to its vulnerabilities to the potential attacks from malicious secondary users. Most existing malicious users detection methods are reputation based, which become incapable when the malicious users dominate the network. On the other hand, although Markovian models characterize the spectrum state behavior more precisely, there is a scarcity of malicious user detection methods which fully explore these features. Through the Byzantine attack, in which the malicious sensor will send falsified local spectrum interference to mislead the fusion center. The advisory can prevent honest secondary users from using the existing white space or allow them to access the channels in use and cause excessive interference to legitimate users, thereby undermine the premise of cognitive radio technology. The proposed method is effective even when the malicious users are equipped with more advanced sensing devices. With the assistance of one trusted sensors, the proposed method can provide high detection accuracy and achieve near optimal collaborative spectrum sensing performance for arbitrary percentage of malicious sensors. Let me discuss about the flow diagram for our process. Initially, primary user and CR users are deployment. Deploy the primary and CR users in randomly, and if the primary user presence means received signal contains both PU signal and noise. If primary user absent means the received signal contains noise alone. Finally, the detection of attacks performed considering both consideration and the noise alone present and the signal with noise present if the primary user present. Then the estimation of probability. Here the probabilities of false alarm and misdetection rate of users are estimated. Here the PFA and PM are estimated. Local binary hypothesis for beginning of malicious users can be formulated. Finally, the local binary hypotheses are applied. The apply K out in rule, that is, after applying the K out in rule, the global false alarm and misdetection probabilities are estimated. Here the both PFA and PM algorithm are used for estimating the global probability of false alarm and global probability of misdetection probabilities. In the for obtaining the optimal K value, we use the minimize base risk criterion. Base risk criterion to choose the optimal value of the parameter K that minimize the base risk. It is depends upon the PFA and PM. Then based on the QFA, that is global false alarm probability and global misdetection probability, we can estimate the optimal value of K using the minimize base risk criterion. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right-click the file and run for executing this process. Here we have to enter either 1 or 0. 1 for PU present and 0 for PU absent. And here we implement the CR network for entire process. And after estimation of entire parameters, we analyze the process. Here the CR network initialization. Here the red color node represents the number of normal users and circle represents the PU node. And this is the cell structures, and this is the cell center, and this is the cell structures. And here this is the estimation of attack strength. Here the estimated value of alpha for both ranges between 0.3 to 0.7. And this is the base risk, that is R of k. This base risk versus threshold. By varying the threshold value, that is for different values of k, we obtain the base risk parameter. Here the NA is varying for estimating the base risk. And here the probability false alarm versus threshold for different values of k. And this is the probability of misdetection versus threshold, that is different values of k. And this is the base risk probability. Here by varying the local detection threshold, that is lambda, for different k values, that is number of users. This is the probability of false alarm by varying the local detection threshold lambda for different k values. And for misdetection probability, by varying the local detection threshold, we obtain the probability. And this is the base risk versus attack strength. By varying the attack strength, we obtain the base risk only for our proposed system. And this is the probability of false alarm by varying the attack strength, and this is the probability of misdetection by varying the attack strength for our proposed system. Here we estimate the base risk by varying the probability of false alarm and the probability of detection. We finally analyze the malicious users. Thank you.